Hi there, here's a quick project that tells you how long you've had your radio keyed up. Sorry for how ugly it is. I solder and code good, but I manufacture lousy. Hi folks, Cycle Camp here. If you're a ham radio enthusiast, you know that there's a lot of people that talk on HF most of the time, and they talk on VHF or UHF repeaters part of the time. And one of the big differences between them is when you're talking on HF with your radio, you don't really care how long you talk or how involved your stories go and all that stuff, and you just chatter away until you're done, and then the next person keys up and he chatters away until he's done, and that's all well and good on HF. But on VHF and UHF, most people are using repeaters, and on the repeater there's usually a time limit, right around in the neighborhood of about 3 minutes, where if the repeater sees the input constantly coming in for that period of time, it says, oh, something must be wrong, and it shuts down. And it usually put out some warning beeps and all that, and shut itself off. But it's very easy for HF guys that spend most of their time on HF to actually run over this 3-minute limit. While a lot of radios have timers in them, you can, like my FT450 has a timer in it that allows me to set a time limit, and my radio will turn off. It does not warn me ahead of time to avoid the situation altogether. It just turns the transmitter or radio off. So I said, gee, wouldn't it be nice to have a little device that could warn me when I was getting pretty close to the limit? So I decided to build this thing. I call it the transmit timer. And basically the way it works is it uses the PTT, the grounding of the PTT line, which can be external on a control port, or it could be from the microphone itself, depending on how the radio is set up. And it watches the PTT line, and when it goes closed, it starts timing. And when it gets to within a certain limit, you tell it how long the repeater timeout is, and then you tell it how early before that you want it to start alerting. And once it starts alerting, the little buzzer will go off. So I'm just gonna power this up for a second here and show you what it looks like when it first comes up. That's the buzzer. So there's my little splash screen. Then it tells you, hey, the repeater timeout right now is set for 3 minutes. And it's going to warning when there are 15 seconds left to that 3 minutes. And now it's sitting there waiting. It's not timing or anything. It's waiting for a PTT to be closed. So what I can do just for fun is I can uses an 1/8" mini jack to pick that up. So I'll plug it in, and then I'll get a screwdriver or something here and short it out. And as soon as it detects that it's closed, it'll start counting up. Now what this will do is this will count up to 2 minutes and 45 seconds, because that's 15 minutes before 3 minutes, and it will start beeping the buzzer once a second for a second every other second, basically. And that's basically how the TxTimer works. So it's pretty straightforward, and when you release the key, it goes back to 0 and just sits there and waits for you to key up again. So pretty straightforward. The way I built it was I used an Arduino microcontroller, and there's really not much to it. I've got some still pictures. I don't want to take it apart and try to show it to you live, but I've got some still pictures, and I think I will show you the still pictures and then explain to you how you set the thing up and all that stuff. So give me a second, we'll go out to So first we have the Arduino Nano, which is the blue chip that's there horizontally, in line with the words, and that provides all the intelligence and all that stuff. Right next to it, almost forming like a T, is the buck converter, which starts with the big electrolytic cap and ends with the electrolytic cap on the bottom. That's to convert the 13.8 volts to 5 volts. There's a 7-position dip switch, where if it's open, it's a logic 1, and if it's closed, it is a logic 0 because it's grounded. There's a bipolar transistor right under the B in bipolar to run the PTT input and isolate the nano from the radio. And there's also a bipolar transistor right above the L. It's kind of hidden between the black and the red wire, and that's to isolate the Nano from the power supply for driving the buzzer. In order to configure this thing, we use a 7-position dip switch. The first 5 positions, 1 through 5, tell you the amount of time the repeater timeout is, and that's in 10-second increments. And then the last 2 digits tell you how far before the end of the timeout you want to start buzzing the buzzer. That starts at 10 seconds, and you can add up to 15 seconds more. So if both switches are turned off, then that's 0 and it's 10 seconds. And the way you see it now, 6 is open, so that's a 1, and 7 is a 0, so that says add 1 5-second increment. So that's how you get the 15 seconds. So you can go from 10 seconds to 25 seconds based on the settings on pins 6 and 7. It's a little hard to see in the picture, but if you look hard, pin 2 and pin 2 on button number 2 and button number 5 are pressed in. This is a binary number, and that number happens to be 5, which is 16. So it's, 1 is 1, 2 is 2, 3 is 4, 4 is 8, 5 is 16, and you add them together. So if you take 16, which is the number 5, on the number 5 switch, and you take 2, which is the number 2 switch, and you add them together, you get 18. Multiply that by 10, that's 180. That's in seconds. 180 seconds is 3 minutes. So that is how you configure this thing for how long the repeater timeout is and how long before the timeout you start buzzing the buzzer. And that's basically all there is to setting the thing up. The device uses an I2C display, and it's a 4-wire input. Basically, the black and red wire are the positive voltage and ground for the display, and the yellow and the white wire are the data clock and the data input, the serial data clock and the serial data input. Pins A4 and A5 on the Nano are used to drive the data and the clock, and obviously just picking up power and ground from wherever we're getting it. Very straightforward, nothing special going on there. And there's nothing else unusual about this except for the use of one of the pins of the Nano to pick up the whether or not PTT is pressed, and we do take that through a bipolar transistor in order to isolate the Nano from the outside power supply. And that's basically it. Everything else is done in software, so it's not a very big deal. Again, I apologize because it's so ugly looking, but that's just because I do well with programming and wiring, but I don't do real well with fabrication. Alright, so let's take a look at the code that runs in the Arduino. This will be kind of fast and furious. Here's just some splash stuff that shows you what's going on and what we did to correct it and all that junk. But this is the basic. This here is the basic how the thing works. This we added the dip switch to allow us to change things a little easier, and then we adjusted because we were losing some time, and I'll show you that later on. That's basically what was going on there. So this junk here is just so you can run the display. You need SPI and wire and all that for the to run the I2 interface. And because it's an SSD 1306 style display, you need the Adafruit graphics library. You don't really need the graphics library, but you do need the well, I think you do need the graphics library in order to create the letters and numbers and stuff, because it is just a pixel display. This particular display is 128 by 32. So, and on a Nano or I2C display, address line 4 is used as the analog 4 is used as the serial data. Analog 5 is the serial clock, and how we're going to reset the thing, all that junk. Nobody really cares. This is all just boilerplate. You have to steal this stuff from other programs in order to make any of this run. All right, these are my global variables. I do have a debugging switch in there. I do set up the serial port on the Arduino to allow it to use for serial debugging if you're running in the Arduino development environment. That was very useful to find out where things were working, not working. I have obviously the number of minutes and the number of seconds that are going to be on the clock. Display, done as a global variable so I can reach them from any routine. The splash sizes, these text sizes, work with the graphics library and say how big the characters are going to be. So for the small printing, like the the TxTimer display and the repeater display, and we're going to start warning people. That's all in size 2. Size 4 is where we get the 4 big numbers and the colon for the clock. The transmit pin, the pin that we look for is data pin 2, which is where we look for the low when we are transmitting. We also have buzzer on pin 13. That's how we turn the buzzer on and off. This gives you the last transmit state. Where was the transmitter last time? Where was the button last time we polled it, because we only poll it once a second or so. And we also turn the buzzer saying, hey, we're not playing the buzzer right now, so buzzer play is not turned on. Our warning seconds, our base for warning seconds is 10, and we can add up to 15 more based on the other switches that are out there. And I apologize, this is not, there you go. You'd have to open this up a little further to get that. That's obviously not there. It was wrapping. So that's a little bit better, but I don't think you're going to be able to see it because that's how the, works, the screen capture I'm using. So I'll leave it there. Then we have the transmit limit, which is a value we will calculate. It's a value we'll calculate based on the switches. So here are all the switch definitions. Where do we find them? All of these guys define all the switches that are on that dip switch. And you'll notice 5, 6, 7, 8, 9, 10, 11. The beauty of that is they're all in a row right there on the processor, on the Nano itself, and you can just stick that dip switch in there and bend the leads over and solder them right to it, and it makes it really easy. And of course, then we have our how much is each transmit switch count worth. And a transmit switch count is obviously the repeater delay. So each repeater delay number is worth 10. That's what we're going to multiply it by. And 5 is how much the increments work. If we're going to say how much are we going to add to the base of 10 seconds for the warning. So we add up to another 5 per switch count, and there's 2 switches, so that can be up to 3. This is all setup work. You only do this stuff once. Again, we're line wrapping here, so don't worry about this. This is just line wrapped. The wire begin, that starts up for us to be able to use the display. The serial begin is for the debugging if you choose to use it. So we turn the buzzer high. That's what turns the buzzer off. And then we set its pin to output mode. Then we take the transmit pin and all the other input pins and turn on the internal pull-up resistors that are inside the Nano, which saved you having to put pull-up resistors all over the board, which was great. This is just a little piece in case you're using a, if you're using a display where you're actually generating a display off of 3 volts internally. But in any event, basically it's saying, hey, I'm trying to initialize the display, and if I don't initialize the display, stop. So basically, if the display's not connected, the thing will just stop. It won't run at all. Here's how we clear the display. So we issue the clear display command, and then you have to display it. The way this display works is when you tell the display to do something, that sets up an internal buffer in the Nano, but it doesn't actually get written out to the display unless you use the display command. So you'll see that all the time. Set text, set cursor, set size, print this line, right? And then print version, and then display it. So none of this stuff has any effect on the display until the external display where you can see it, until you say, okay, now display what I just told you to display. which is kind of neat. So and that stays up for 3 seconds. Delay is in milliseconds, so that stays up for 3 seconds. So we display the timer, then we go to the clock, and then we show the limits and all that stuff. So we display we set the limits, then we display the transmit limit, which is the repeater's time delay. Then we set the warning limit, and then we display the warning limit for 3 seconds. And that's all in initialization. That just gets us to the point where we're going to put up the whole big thing. So we check to see if the PTT pin is high. If the PTT pin is high, we say, yep, just turn everything off. Make sure the buzzer's not running. Remind ourselves we are not currently playing the buzzer, and display the time. So basically, it just goes through resetting itself over and over and over again. However, and this is a polling mode, so we're polling TX pin, digitally reading it, and we're saying, hey, if it's high, then reset to 0, turn off the buzzer, and go away. Otherwise, we look and we say, hey, the thing is low now, we need to start counting. So we take our seconds value, we add 1. If it's greater than or equal to 60, and most people, you would just use 60, but us real programmers, we always check for an outer range condition, which might happen if you screw up someplace else in the code. We check to see if it's greater or equal to 60. If it is, we set it to 0, and we set the minutes to minutes plus 1. Same thing with minutes. If once we hit the 99th position of minutes, we reset seconds to 0 and minutes to 0, and we display the time again. Then we check to see if we're supposed to be buzzing, and we check transmit warning. So we're counting up, 1 second, 2 second, 3 second. Transmit warning subroutine tells us, hey, by the way, you're in the warning period now. You should be manipulating the buzzer. Well, if we're not in, that's what the exclamation point means not. If we're not in that warning, then you don't have to do anything. Otherwise, you buzz the buzzer every other second. So if I'm not already playing the buzzer, okay, then I need to turn it on. So I write the buzzer pin low, which turns it on. I set buzzer play to true, and that tells me that the buzzer's playing, and I take, I'm going to set the buzzer play, which basically I just complement it. I just say buzzer play is now equal to not buzzer play. So if it was a 1, it's a 0. If it's a 0, it's a 1. If I did play at the last second, same thing. I write digital write high, and I say buzzer play is not equal to buzzer play. Now this is very simplistic, very brute force. You could stream like this. You could directly read. I believe you can read the output ports as well. So you could do that. You could just complement it and write its complement. You don't have to say write buzzer pin high or write buzzer pin low. You could say write buzzer pin to the complement of buzzer play. But just to make it simple and easy for people to understand, I left it easy. Okay. And then when you're all done with that, you just sit around and wait for the rest of the second to go away. Well, if you delay for a full 1 second, what's happening is all of this code takes about 22 milliseconds to run all the buzzing code and all that stuff. So to make up the rest of the second, I subtracted 22 milliseconds from the 1000, and that's how you get this delay. And that was the last change we made. So it kept more accurate time. We wanted to keep more accurate time. Okay? And that's basically how the whole thing runs. These are just some of the subroutines. So this displays the time, and it takes the seconds and the minutes, and chops them up and converts them, puts the semicolon between them, all that stuff. This here is for leading 0, right? If you only have 8 seconds, you want to print 08, that kind of deal. So that's what that's all about. Same thing with minutes, right? If the minutes is less than 10, then print a leading 0, and all that kind of junk. Obviously, there's other ways to do this. There's formats you can use and stuff, but like I said, I'm just keeping it simple. The transmit warning, this just checks to see if we're in there. We take the limit, we convert it all to seconds, and then we take the limit plus the warning seconds, And if that's greater than or equal to the transmit limit, then it's time for us to start warning. And we return true, and otherwise we're not warning, so you could return false. All big stuff. This is where we set the switches. This is where we read the switches to set the repeater time. So you see each switch 1, 2, 3, 4, 5, and they're all in binary multiples. So it's 1, 2, 4, 8, and 16. We add them all together. That gives us a count, and that count is going to be multiplied by the increment, which we said the increment was 10. So it's going to take the switches, it's going to take and multiply it by the increment, and that, which is 10 seconds, and that's going to give us the value. So in the pictures that we showed earlier, we had it set to 18. 18 times 10 is 180. 180 is 3 minutes. So that was pretty good. Let me see. So the warning limit is basically the same idea. We read the switches, we multiply them by the 5, and we, oh, I screwed that up. I'm sorry. That temp switches shouldn't be times a hard 5. That 5 should have been the variable up above. So sorry about that. Just noticed that. That's what oops. But in any event, it still works because it's 5. But that's basically what you're up to. So your display, and then this is display. To display it, it's a little tougher. You got a lot of work to do in order to display it. So this displays the limit for the repeater, what its repeater limit is. This displays the warning limit, tells you what the warning is going to be. And those are all the support routines that you call from either setup or from inside the main code. So not a lot of code here. It was about 300 lines of code. Not a big deal. You can see it's very straightforward. It's very brute force, but it works, and that's the important thing. So anyway, I hope you enjoyed it. It was a lot of fun putting this together. It was just something to do. I had a shoulder surgery where I had my shoulder removed, and I had a fake shoulder put in. And this was one of the few things I could do once I got to the point where I could type with at least one-handed again without too much pain. So I hope you enjoyed this, and have fun on the radio, but don't time out the repeater. So long.